Hey, Brooke.
Hey, Miss Marks.
How are you?
I'm good. How are you?
Good. It took me a minute to figure out how to share the document. You'd think I never did this before. I
That's fine.
changed. I changed Tuesday's time. I'm really aiming for 3 o'clock for you
Okay.
guys because I
Yeah.
think that gives you enough time to get home from Chem Lab. Is that correct?
Yeah.
Okay. That's what I'm trying to do.
Yep. That helps a lot.
I'm so glad. I want it to. Is there a specific question
Um,
on today's or just start anywhere or start at the
um,
back and move front?
for me, I did like the whole first page and
Praise the
like I got
Lord. You're a
yeah.
genius.
And I got to 17 on the back, but I'm stuck on like 18 and then I haven't gotten to like the next page at all. But then I
Okay.
have the last page finished because we
You
did the
go.
last page in class.
You go, girl. You're doing good.
We're getting there, so that's all that matters.
All right. So should you got stuck on, did I understand you got stuck on 18? Is that correct?
Yes, ma'am.
Okay. I'm going to try to blow up this page just a little bit. Um, so we've got the function f times g at t. So basically that means you're not going to, at t means you're not going to replace the value with anything. So you're going to literally take g and plug that in wherever there's a t into f. So you'll have 4t minus 5 squared plus 4. So you have to FOIL the 4t minus 5 out. So that when I say that, that kind of, I hate when they use the letter T. I'm just saying. Because, it can kind of gets confusing, you know,
Yeah.
with the pluses and minuses. I do try to put a little tail on it
Yeah.
to hope that helps a little. But okay, so 4t times 4t is 16t squared. And then outside 4t times a negative 5 is negative 20t. And then negative 5 times 4t is negative 20t. And then negative 5 times negative 5 is a positive 25. Combine like terms. And so then, back over here, this should have been that. Sorry about that.
No, you're fine.
And now I've got this plus 25 and that plus 4. So I'm just going to write plus 29. And I must have done something wrong. Yay! Let's go back over my work. I was supposed to plug in G, right? Yeah. Oh no! I did a composite. What I did was a composite function. I did this down here.
Oh,
Yuck. I'm so sorry, Brooke.
it's okay. It's okay. We're learning together.
There you
That's
go.
even better.
And all Miss Sparks needs to do is learn how to read the problem and get out of the foggy Thanksgiving break brain.
Oh, right. Yeah, Monday was all of that.
Wasn't it?
Yeah, like every
Oh,
class.
I made myself laugh. I made so many simple mistakes yesterday. I'm like, sweet Jesus, help Mrs. Sparks. Okay, so we are going to FOIL, though. That part I had
Okay.
right. So t squared times 4t is 4t cubed.
Mm-hmm.
And then outside is t squared times -5, which is -5t squared. And inside is 4 times 4t, which is going to be plus 16t. And then the outside is going to be minus 20.
Okay.
So there's an answer.
There you go.
Yay! I knew you could do it, Mrs. Sparks. If you just start the problem right, it's half the battle.
That's true.
You do have to start the problem right, though, you know?
That is helpful.
Yes. All right, so 19. This is a division problem, and I can see that up front. So there we go. So you've got x squared. I think this is one that we're just going to say, praise the Lord, over -x minus 5. And look at that. It's already an answer.
Oh, that's so cool. I wish they were all like that.
Cool?
They were like multiple choice.
Really? Right. Wouldn't that be great?
Yeah.
Now, remember how you and I were having this discussion the other day when sometimes the domain is limited? Like if it were to ask you that question, like, what is the domain for this function?
Yeah.
Okay. Each one of these individually would be all real numbers. But once we put it into this, it would be a limited domain because you would then set that denominator equal to 0.
Right.
And then solve. And you would find that wherever x is -5, it would be all real numbers except for x is equal to -5. Because you can't have a 0 in the domain. And I know, and the reason why I wanted to make sure I cover that in math lab again is you are not alone in wanting clarification on that little piece of information right there.
I gotcha.
Because the domain and range is kind of hard. Yes? Okay. Did I hear somebody say Miss Sparks? Yes.
Are you recording this?
I am.
Are you going to go over like all the problems?
I'm probably not going to go over all of them, but I'm going to go over quite a few of them.
Like a couple from each section?
A couple from each section? Yeah, I could do that. You mean even from the beginning?
The thing is that I have a lot of other things I need to do right now. I just want to make sure that I can come back and review this. Okay.
If you could email me and specifically say like 1, 5, just like that, it would, and then it would pop up on my phone as a reminder. That would be great. If you don't mind, just shoot me an email real quick.
Okay.
Thank you. Okay. All right. These are the composite ones.
Okay.
So this is the one that I tried to do earlier that we didn't need to do till now.
Right. Okay.
All right. So we're going to plug in G into H. Okay. So we're going to take this and plug that in for where the T is.
And how do you know like that that's what you're supposed to do rather than like the ones above?
Okay. These, like that's a multiplication. That little thing that looks like an open circle, that is the same thing. In the book, I think we write them like this.
Oh, yeah. I think Miss Wynn sent an email about that.
Yes, it's all the same thing. But this, I think, honestly, but I'm glad that we can see it both ways because actually on ACTs and SATs, it's actually written this way and this way.
Okay.
Both ways. But more frequently, the way this is, to be perfectly honest with you, right here. Oops. either that or like the SAT is one way and the ACT is the other. Now I can't really remember.
Yeah.
We should ask Miss Wynn since she teaches ACT, SAT prep. We'll ask her. She'll know. Okay, so now we're just going to distribute the 4. But that's the distinguishing difference.
Okay.
Though, is the syntax of the problem. And, I needed to be paying much better attention earlier. Okay. All right. Did Miss Sparks not add well? Yes, no, she can't multiply. Help her. It's a good thing it's multiple guests today,
That is true. I think that is a blessing for sure.
Yes. For Mrs. Sparks, it is indeed a blessing because 4 times 4 is 16. All right. Brookie, I probably am not helping more than I'm probably hurting more than I'm helping today.
No, you're doing great.
So for those people who are watching the recorded math lab, bless you, child. All right, so H, and I will also tell you the other thing. One of the other things to watch out on SAT, ACT is they do tricky things like they'll list them in this order, but then flip this. So it might be like H of G, like that.
Oh, I got
you. So you would have to actually then plug G into H. So that's another thing you got to be real careful about.
I gotcha.
Okay, so you got to kind of watch that and don't assume that it's going in that order. So we've got H, and we're going to plug that into N, or into G, where there is an N. So -3 times 2N plus 2 plus 5. Let's see if I can distribute more effectively this time. -6N. And then -3 times 2 is -6 plus 5. So I've got -6N, and -6 plus 5 is -1.
Yep. Hey, that was good.
Yay! Praise the Lord. Okay. And then 22 and 23. So this time what you're going to do is actually find the value of each of the functions defined at 8 and then subtract each individual value.
Okay.
So if I plug in 8 into f of 8 equals 8 plus 3, so that means it equals 11. And then I plug in g of 8 into 8 squared minus 3 times 8. It's going to be 64 minus 24. So that's going to be 40. So then we've got 11 minus 40. Find the difference, give the sign of the higher. So that's -29.
Oh.
A negative, yes.
Yeah.
Okay, and on this one, this is a composite function. It's that same thing that we had earlier, but it's written in the other syntax. But what you're going to do is actually plug the value of -7 into G. So you've got G of -7. And then you'll have 7 squared minus 2. So 49 minus 2 is 47. And then you will take H and plug this value in. So the value that you get by plugging in -7 into G, you will plug in. And then 4 times, oh Lord, 2.
I think it's 191.
Yes, ma'am. Thank you for having my back, though, because you've seen how it goes here today, rookie. It's not been totally pretty.
You know it. Just
We're a
happens.
little, coming back from the break. It's a little ugly over here too, Plus, I feel like I've got so much stuff to catch up on because I was sick before break.
Yeah.
So I'm still kind of playing catch up with that, unfortunately. Yeah. Okay. How are you doing on the inverses? You want me to go over a few of these?
Yes, if you don't mind.
Not at all. Okay. I have this weird systematic approach.
Okay.
Where the first, because I think sometimes they can be a little daunting, to look at, and you're thinking, oh my gosh, this is huge steps. So I have these what I call confident building steps. And hopefully they work. But I'm weird, and I always rewrite my problem. And then I change my fancy g of x to a y.
Okay.
Or f of x or h of x or whatever it happens to be. Okay.
Yep.
And then I swap places because I'm doing the inverse with my x and my y. So I bring my x over. And these are steps that we can feel pretty confident. Oh my gosh, I think I can get these right. And they kind of like, okay, that's systematic. And, I'm doing good so far, right?
Right. Mm-hmm.
Okay, so now, what I like to remind everybody is that when you're undoing an algebra problem, you're actually doing PEMDAS in reverse.
Okay.
And what I mean by that is if there's any adding or subtracting that's not in a grouping, and remember a fraction bar is really a grouping. If there's any adding or subtracting, you do that first. But in this case, there's no adding and subtracting outside of a grouping.
Right.
Okay. So then you move to multiplication and division. And there is some division going on. And because all of that grouping is being divided by 5. And to undo division, you multiply. So I'm going to multiply both sides by 5.
Okay.
So that would give me 5x equals 25 plus 7y. And now I want to start back over on my PEMDAS. Okay. Is there any adding or subtracting going on? We want to do that first. Well, 25 is being added to 7y. And the understood sign that's in front of 25 is a positive. So to undo like positive or adding, it's negative. So you're going to subtract 25 from both sides. So I have 5x minus 25 equals 7y. Well, so now I've conquered the adding and subtracting. And now there's multiplication going on. So 7 is being multiplied to the y. And to undo multiplication, it's division. So I'm going to divide both sides by 7. And then for my final step, I'm going to actually change my y back into that fancy function format. But this time I'm going to add the little -1, which stands for inverse, and write my problem.
Oh.
So those, I don't know, it sounds really weird, but those confident building steps
Mm-hmm.
kind of get you started and give you like a systematic approach to each one.
Yeah, I like that.
Because on these, there's a lot of steps. And just like I was getting, kind of twisted around earlier, there's a lot more places in these to get squirrely and get sidetracked with, simple mistakes. So I really need that systematic approach. It's very important for me.
Mm-hmm.
So I kind of have these weird things that I walk through. So that's probably how I'll do each and every one of these. I don't know. Does Miss Wint, bless her heart, she probably doesn't go through the daunting steps that I do, but
yeah, I don't really remember doing these in class.
Oh, okay.
But
what was it? Was this before Thanksgiving?
I think it was because
Oh.
I just know that yesterday we did like the back page and she went over like 3.6. So
Okay.
I kind of don't really remember doing these.
Yeah,
It was a while
well,
ago, I guess.
it was a minute ago. That's for sure. It feels so long. Why is that?
I know.
Well, and bless your heart, honey, you're a junior.
Mm-hmm.
It happens.
Oh yeah.
You're gonna lose moments of your life. No, I'm just kidding. I'm just kidding.
So hard.
All right. So now what we're gonna do is change spots, and oh, it's a glory in. So what goes within? We're just gonna stick Y there, I guess. Oh Lord. And then we'll swap places with our N and our Y. And we're going to solve for Y. So once again, working that PEMDAS in reverse, we're looking for any addition and subtraction first. And so we do see some. So we're going to subtract 4 from both sides. And that's going to give us N minus 4 over here equals 2Y. And now we see some multiplication going on. Well, actually, it's multiplication. And to undo the multiplication, we're going to divide. So we have N minus 4 divided by 2 equals Y. And then the last step is to change back to our fancy function notation. Like that.
Perfect.
So not too bad so far, right?
Yeah, that one wasn't bad. This next one doesn't look pretty, but
oh, she is ugly. But we can do it.
We can do it.
That's right. So, okay, we have our confident building steps, which by the looks of this one, we better get those in.
That's so funny.
All right. And then we're going to change our fancy G of X to a Y. And just think how brilliant we're going to feel when we get done with this,
Oh, yeah. This one will be a very positive experience.
Won't it?
Mm-hmm.
Now we're going to swap places with our Y and our X. And actually, this one is really uglier than then at the end, you'll be like, wow, that wasn't so bad.
Yeah.
And sometimes it's the ones that look really, really simple that you're like,
yeah,
ugh.
That's true. And then you get tripped up because you think that they're easy and then they're harder than you.
Yeah. Like these that have all this complicated stuff in, you're like, oh. And it wasn't so bad. So to get rid of a fifth root, you want to raise it to the fifth power. And whatever you do to one side of an equation, you do to the other. So now we've got x to the fifth over here. And we've got a negative y minus 2 all over 2. And don't forget, this baby right here is a little grouping, so they can't be separated yet when we're going through our PEMDAS in reverse. So now we're dividing. This is all being divided by 2, so we want to undo that first. So we're going to multiply both sides by 2. My dog is snoring. And so now we've got 2x to the 5th equals negative y minus 2. Okay? And now we're going to undo that addition. By adding 2 to both sides. 2x to the 5th plus 2 equals negative y. They do a lot of this, it seems, in CUDA for whatever reason. They always love to end with a negative y. So you can either divide or multiply by a negative 1. Essentially, it does the exact same thing.
Okay.
And then that's going to change the sign for everything on this side and then leave us with a positive y over here. And then our last step is to convert that y back to its fancy function notation. And there you have it.
Yeah, that one wasn't as bad as it looks.
I know. So much uglier than how she really turned out.
What's up, Miss Parks?
Hey, Braden. How are you, honey?
I'm doing good. How are you?
I'm doing great. I'm so glad that you came.
Thank you.
Because I want to tell you something.
Yes,
On
ma'am.
top of, I have not had a chance to do this, and I feel really bad. Because I've been in math lab and had a couple of other family things that I needed to take care of.
Yes, ma'am.
And I wanted to tell you guys that test that I assigned from the textbook today.
Yes, ma'am.
You can take today, tomorrow, and Thursday to do because I postponed the test to Friday.
Yeah, we're gonna do in class tomorrow. We're just doing a review day, right?
Yeah, we're doing a review day so that when I was going through some of these problems, I thought it would take you a minute to get through these. So I don't know if you want to post on our Google Classroom the fact that obviously that assignment isn't going to be due until Friday anyway, but I'm going to go over it specifically tomorrow.
Okay. Yeah.
Does that give you some relief?
Yes, ma'am, it does.
Okay.
Because I was like, oh, she's gonna give us more classwork tomorrow, and then she's gonna give us even more worksheets to do Thursday. So
no. It'll be this worksheet, and there might be one other short review worksheet. But nothing more like from the textbook, and no extra classwork. We'll have today and tomorrow to do this.
Awesome. So whenever you're done working with Brooke, do you mind if we get just start on number 9, because that's when I started
from the textbook or on this review sheet?
On textbook questions.
Okay. Yes, I can do that.
Awesome. Thank you.
Did you finish this review sheet?
No, ma'am, I did not.
Okay. All right. So is this helping you as well?
I just got on, so I haven't been able to see any of it. But
okay. Well, Brookie, where did we start?
We started
at 18. Was that right?
Yeah, I think it was 18.
Okay. And we've done quite a few of them since then, right?
Yeah, we've done through 26.
Oh, wow.
Okay.
That's cool.
Okay. All right. So hopefully that will help.
Awesome.
Too. Okay. No problem. And then let's see. So for number 27, have you already worked this one, Brooke? Are you ahead of me?
No, I haven't.
Okay. You waited for me?
Yeah.
You're so sweet.
Mostly because I don't know how to do it, but
Did you do these confident building steps? They're supposed to build your confidence. Like, yes, I can do this. Watch me.
I mean, I probably can.
You can do these 3. These are good.
Yeah.
They're Mrs. Sparks's confidence building. Rewrite the equation, then rewrite the fancy f of x to a y, and then swap your x and y. And for whatever reason, it kind of gives you that jump start that you can do it.
All right, I've gotten there now, so that's good.
Praise the Lord. All right, so now what we're going to do is do our PEMDAS in reverse. And so there's no adding or subtracting, but there is some multiplying before we ever get to those exponents. So what you're going to do is divide both sides by 2. And so now we would have x over 2 equals y plus 1 cubed. Now, this is where it gets ugly. See, this one started looking like, remember how, Brooke, we were talking about this one looks like it's going to be ugly?
But then it
And
wasn't
it turned out not so bad. This one is, there is a lot to this one. So I probably shouldn't have written so sideways. As a matter of fact, I think I'm going to erase my last step. If you guys don't mind.
No, you're good.
And I'm going to bring her over here because we're going to need a little room. Just saying. Oops. Don't rewrite that part, Miss Sparks. Y plus 1 cubed. All right. We have to get that y outside. So we're going to take the cube root of both sides. And so now I have the cube root of x over 2 equals y plus 1. And now we have to subtract -1 from both sides. And we got y. So you think you're done, right?
Yeah.
But there's a problem.
Trick question.
Because right here, this cube root of x over 2 is really the same thing as the cube root. Oops, Lord Jesus, help me Sparks roll. Thank you. Is the cube root of x over the cube root of 2 minus 1 equals y. Well, you can't have a radical in the denominator.
Right.
You have to rationalize that. And to rationalize that, you would have to take how many more 2's is it going to take to get that 2 out? There's only 1 there. And in order to get it out, in order for it to be perfect, to get out of jail, you need 2 more.
To make the 3 for the cubed root?
Yes, ma'am. That's it. Exactly. So, in whatever you do to the bottom, you have to do to the top. That's my 2 2's. Does that make sense?
Yes, ma'am.
If I write it as a 4, are we okay with that?
Yeah, you're good.
Okay. So now I have, oops. The cube root of 4x.
Miss Sparks.
Yes, love.
I'm just going to totally guess on this one, but would the answer be C for 27?
No.
Okay.
Look again and see if you see anything closer to what that is right there.
That'd be D.
Yes, it is. And let me explain. And you're like, well, Miss Sparks, you have a 1 there. And let me explain why. And they're not leading with it. But
Well, no, I think I understand why actually.
really?
I mean,
Tell me why.
well,
I'm so
basically,
proud of you.
thanks. So basically, well, you can like distribute the 2 to all of the equations. So, or before that, you got to cube everything. So you can have x cubed plus 1 cubed, or which will be 1. Yeah. So then you can put in, it'll be 2x cubed plus 2, and then just like the cool thing about math is that you can like make some good guesstimations, and so it's going to be D.
Right?
Yeah, I just thought it was because I was, totally guessed actually. So it's all good.
Yeah. Well, yeah. I mean, that is true.
Yeah.
That is true. That is the cool thing. I love that you call math cool. That just made my day.
I mean, I was actually lying to you, but I'm just kidding, Miss Florence.
This one, you see how this whole thing is divided by 2 up here?
Yes, ma'am. That was
All
from
right.
the numerator, which the 2 times 1 was.
Yes. If I was going to express a -1 with a denominator of 2, and they also moved it out front, so that would be this same 1 would be -2 over 2. Oops. Minus cubed root of 4x over 2, which can be written the way they wrote it, because this is an understood plus sign out here. Now, here's the thing about multiple guess tests. If you would have gotten to here, Miss Wynn and I would be probably very happy. And we wouldn't have even thought, oh, you need to express that all over 2. We would have just been happy that y'all did that. But with a multiple guess choice, obviously you've got to kind of figure out, which one is the best choice based on your answer once you get there. So just kind of, that's why I wanted to show you why that was. Does that make sense?
Yes, ma'am.
Brooke, did you follow that?
Yeah, I did.
Cool. Okay. All right. See, now that one looked like it was going to be okay at the beginning.
Yeah, and then it was not.
And then it took a drastic, ugly turn along the way.
Yeah.
Now, for math people, we like stuff like that because we're weird. No, I'm just kidding. But that one took a minute. And some of these kind of do. I believe, and Brayden, you're not going to like me after you hear this. And you're really like, I want Miss Wynn back. But Miss Wynn gave her class a choice of 40 or 41 on this test, on this review sheet. I did not, however, give my class that choice. They have to do 40 and 41.
Oh.
Well, dang. So wait, you're gonna make me do all the problems now?
Yeah, no, on this review sheet, not on that test thingy, not the textbook thing. And you've got
the textbook thingy. I don't have to complete it.
The textbook test. There's already selected problems on the lesson plan, and now you've got Tuesday and Thursday to do it, plus class day tomorrow.
So if I go to the chapter 3 homework assignment thingy, it's going to tell me that I don't need to do the test?
No, you still need to do the test. You just have an additional day to do it.
Yeah, it says Page 169 through 55 odd, 3.2 study guide 1 through 12, and then some other problems with it. And then all the way down at the bottom says test book, test, blah, blah, blah. All of what the lesson plans was.
Oh,
So,
okay. But
yeah,
before it was due tomorrow. It's not due till Friday.
Yeah. I got that.
Okay. So hopefully that helps.
Yeah.
Because I'm not assigning extra work.
Yeah, that's good. I appreciate that one.
I thought you would. These take a minute. I'm working on my confident building step right now.
Yes, I got through my confidence steps, Miss Sparks.
Did you? Good job.
But then I stopped there, so.
Oh, I love you. Okay, so PEMDAS. Is there any adding and subtracting going on? That's what we have to check first. And there is. So you want to subtract. We're doing PEMDAS in reverse. So we're subtracting. Oops, why did I write the X? Subtracting 2 from each side. And now we've got some multiplication going on. And well, actually, technically, it's division. So we want to multiply both sides by that y plus 1. Feels weird, doesn't it? But just stay with me.
Okay.
So this one looks ugly, but then she gets pretty real fast. Now we actually have y plus 1 x minus 2 equals 2 because this cancels that out. And now what we're going to do is divide, because this is multiplying right here. It's 2 binomials being multiplied, but we're going to divide both sides by x minus 2.
Oh.
Yeah. And now we're going to subtract 1 from each side. And then we're going to go to our confident building step, or reversing our confident building step, maybe is a better way to say it. So we've got G inverse of G of X, 2 over X minus 2 minus 1.
Yeah, that one was not that bad.
It wasn't. See, it just looked ugly. I said,
it was very ugly.
So it's literally walking through the steps and doing that. And in all honesty, I tell this to my Algebra 1 students. I tell this to my Algebra 2 students. I tell it to my Algebra 3 students. When you're breaking down some of these more complex, and you could even write it GEMDAS if you want to remind yourself that it's groupings so that you keep things like this together. And just go through it and know that you're working from the bottom. Like in elementary and junior high, you're working from the top down. And in senior high, it seems like you're going from the bottom up. So just break that down like that.
Yeah.
Okay. Now 29 through the what up? Oh yeah, there's some pretty ones on this page.
Yeah. I did like 29 through 37, and then I did 38. So, or 39. So I was wondering if you could do 38 and then 40. Because we could pick 40 or 41, so whichever one.
Okay. What I would like to do, just because it's Math Lab, if you guys don't mind, I would like to actually do number 31 from this section. just to have one in Math Lab as an example, and it seems to be, has some weird looking things to it for this particular section.
Oh, yeah, that's fine.
So for this one, doing the PEMDAS in reverse, trying to get that radical by itself, I'm going to divide both sides by 8 first. And now I'm going to square both sides to get rid of the radical. And now I'm going to subtract, because I've got some adding and subtracting going on. So I've got 20 equals negative 4b. Then I'm going to divide both sides by negative 4. And that should give me negative 5 equals b. And you really, obviously we don't have an answer of no solution up here. And there's only one answer, so you can kind of tell that the check is there. But technically what you should do is plug that negative 5 back in here to check it, to make sure that it checks. But negative 4 times negative 5 is a positive 20. And a positive 20 plus combined with 5 is 25. Square root of 25 is 5. 5 times 8 is 40. But you should always check it to make sure there's no extraneous solutions. So that's why they say that, because the deeper involved that some of these get, like when you get to these radicals down at the bottom, the more likely that is to happen. Braden,
Yes, ma'am.
are you still with us?
I am.
Is there any on 29 through 32 that you would particularly like me to do other than the 31 that I just did?
30, number 32, 29. How about just all of them? Sounds like a good idea, right?
Just pick one and I'll do another one.
30 we'll start out with.
Okay. So on that one, you can only work outside the radical at first, because really whatever's under that radical, if you're thinking about that PEMDAS in reverse, that's technically a grouping. So that's got to go last. But you see that there's adding going on, and that's at the bottom of that PEMDAS thing. So you're going to add 8 or add 5 to both sides, and you're going to get a positive 2 over here. And then you've got root 9 minus n. And to get rid of the root, you square both sides. And so that gives us 9 minus n equals 4.
Wait,
and
I think I might understand this. So you subtract the n from the other side, you're going to have a negative 1n, which equals negative 5. You can divide the negative 1 by the 5, and that's going to get you n equals 5. Correct? So your answer is C?
Yes.
Oh, yeah. There we go.
You're a genius.
Oh, not really. I suck at math.
There you go. All right. Let's take a look at one of these from the next section.
33 and 34.
Say that again.
33 and 34.
You want me to do those?
Yes, please.
Okay. All right. So the very first thing that I'm going to do, because if I'm thinking about this, I know that once again, I just keep reiterating. I know it's boring. That you want to do the PEMDAS in reverse. So I can't deal with the grouping or the exponent because they're at the top. So I'm going to divide both sides by 4 first.
Wait, why?
Because if you're thinking about it, like I said, when you're doing PEMDAS in reverse,
Oh, you got to divide by 4 for both sides.
You're checking for addition and subtraction, and there aren't any outside of groupings. So then you're looking for multiplication and division, and this is being multiplied. So that's the part that you're going to do first, and that's why. Okay?
Yes,
so
ma'am.
that gets rid of that.
2048 divided by 4 is 512.
Praise the Lord. Thank you for letting me know.
Yes, ma'am.
All right. Now, to undo this rational exponent, I'm going to multiply both sides by the reciprocal of that rational expression. What is the reciprocal of 3 over 2?
2 over 3.
Correct. So that gets me x minus 2 over here. And then I've got 2 over 3 here. And you're like, well, how does that make anything better, Miss Sparks?
Because
Now I want to take the cubed root, because I really want you guys to understand what this really means. Okay, because I know you can plug that in your calculator and you can get an answer. You can raise 512 to the 2/3 and get it. But let's just pretend you didn't have a calculator. Okay, everybody freak out. No, I'm just kidding. It is the cube root of 512, which I believe is 8.
60.
Is that correct?
Well, I did the 2/3 thing at 64.
Right. It is. But the cube root of 512 is 8.
I got you.
And then 8 squared is 64.
Yeah.
Because really, that's what this is, the denominator. And that's the part that I want you guys to be able to know, is that the denominator is the root, the numerator is the power. And that's really, really important to know, to be able to break these things down, because I know you can plug all this stuff in your calculator. But remember, on the test, you're really technically there's certain questions that it asks you to solve things like this without the use of a calculator. So you need to know that the denominator.
To us?
I'm sorry?
You're going to do that to us?
Yes. But only because I love you.
I don't know if that's love, Miss Sparks.
That sounded like an evil laugh today, didn't it?
That was an evil laugh. No, I'm just kidding.
So x equals 84. And there you go. Isn't that a beautiful thing?
Yes, ma'am.
So does working the PEMDAS in reverse, does that kind of help you guys understand why you do certain things first?
Yes, ma'am.
Yeah, I think so.
Okay. And I'm telling you, there are definitely times I still write it at the top of my paper, because the more intricate some of these get, it's just important to remind yourself, okay, what am I going to do next? And remember, after each little step, like after you get to a grouping and you're breaking it down, sometimes groupings, you'll have to even go through those processes again, beginning all over again, looking for adding and subtracting first, then multiplying and dividing, and going from there. So you just kind of almost have to take it each step of the way, breaking it down like that.
Can I try number 34 by myself real quick?
Absolutely. I would love that. And you can tell how long it takes me to erase.
Yeah.
I'm going to erase this up here because it's just like hanging out. Just don't watch me.
Don't watch you? Okay.
Don't watch me.
Alrighty.
Oh, I need a calculator. Don't tell. It almost seems pointless when they have you do that kind of stuff right there, doesn't it? Did you feel that way, Brookie?
I
Yeah.
figured it out, Miss Sparks. Is it D?
34. Is it D, Brookie?
Yeah, it is.
It is.
Heck yes.
How'd you do that? You're so smart.
Oh, thanks, Miss Sparks.
You're welcome.
Just, I had a good teacher.
Oh, you're so sweet. So this is 729 equals P to the 3/2. Multiply each side by 2/3. Is that what you did? Am I doing it right?
Yes, ma'am. And then you're going to get 81 equals P.
All right. Because I guess the cube root of 729 is 9.
Yes, ma'am.
And then that would be 9 squared.
Yep.
All right. Cool.
So I understand that section. Brooke, do you have
And
any
moving right along to the good section. We saved the best for last, right, Brooke?
Oh, that's right. These took so long. Like we worked 39 together. It literally took up the whole bottom section of my paper.
Yeah, I'm going to be honest with you. I'm going to do 37. Then I'm going to move to 30. I'm actually going to do 39, 40, and 41 on Math Lab. Okay. But I'm going to do 37, 39, 40, and 41 because once I do, I guess I could do 38. 38 is the harder of the two, but I don't know. It doesn't matter. But then I'll do those. But I'm actually going to have to pull up a blank sheet of paper because there's no way I can do them on this.
Yeah.
Y'all would. There's not enough room.
I got you.
Hey, Miss Spark, I have a question.
Yeah. Yes, love.
Could I save those problems to do in class? Or Brooke, do you need are you needing her to do these for you?
Yes, that's one of the reasons that she came.
Yeah, just 40 or 41 is fine.
Okay. Well, I was going to say the other thing. Well, I could do 40 then.
Yeah, that would be fine.
With her, but Brayden, I was going to say, I will definitely work through the test tomorrow in class for sure, the textbook test.
Okay, so I'll wait for the test tomorrow and just work on the worksheet then today.
That's what I would do.
Okay.
And,
I have some questions from the earlier section of the textbook. Or not the textbook, of the
worksheet?
Yes, ma'am, the worksheet.
All right, then we'll go back to do that and we'll make sure this gets completed.
Awesome.
For you. All right. Not a problem. So I'm going to square both sides and then look at that. Once you square both sides, it's just a beautiful little algebra problem. How we missed those, right?
Yeah.
Oh, yeah.
So I wish they're back in Algebra 1 right now. That would be fun.
So we've got R plus 4. And then subtract 4 from each side. 3 equals R.
Wait, so that's your answer?
Yep.
Oh my gosh, how freaking simple is that?
And 38 is the same way, buddy.
Really? So you just got to square it and that's it?
On 38, yeah. Well, technically, it's what you do on 39 too, but then you have to FOIL it. It's pretty, isn't it, Brooke?
So pretty. I love that one.
I thought most of the students did. Yesterday, when they saw the minute that I bracketed that and said we had to FOIL, I lost people.
Oh, yeah.
They'd fallen in the aisles. No, I'm just kidding.
My whole class was confused. Literally the whole class. We were all what are we doing?
Lexi even asked me in a different class. She was like, do you even understand any of this? Because I don't understand. Apparently Miss Wynn did a whole entire page. The whole entire whiteboard was filled with just one problem. And it was 39 or something like that. Is that right, Brooke?
Yeah,
Yes.
it was 39. It was a whole whiteboard, and we were all so confused. Really.
Yeah. We're finna. You want me to do 40?
Yeah, if
Bricky?
you could do 40, that would be wonderful.
All right. And then Braden, we'll go back and do, you'll see. It's an entire whiteboard. That's why I opened a whole new document just for you guys. Oh, this one's kind of different.
Yeah, it's something. I don't know about this one.
There's multiple ways to approach this one. I'm just trying to figure out how I want to do it. I think I'm going to move. Yeah, that's what I'm going to do. Because you could actually square just this side if you wanted to and foil that. That's one way to do it.
Okay.
Can all of the problems be like number 37 and 38, please?
No. All right. 4 minus a equals root 7a plus 4 minus 4. So I'm going to square both sides. And that's going to give me 4 well, the internet is lagging, so it's going to be pretty now. 4 minus a. I hate that y'all can't see that other part.
Did I get like another sheet of paper, or do you think I can write?
Oh, yeah, sweet pea. Yeah.
Oh, crud.
Right, Brooke?
Yeah. Yeah, I would get another piece of paper.
Oh, boy.
And I got to rewrite this because of the lag in the internet. I'm sorry, guys.
You're fine.
Yeah, the funny thing is, Miss Sparks, is like, because I sit next to Rachel Shannon, and she's a math wizard. And it's just like, I'll look at her paper, you know, not on tests or quizzes or anything like that. I don't cheat like that.
I got you, honey. I know. You're a man of integrity, and I know that about you.
I'm trying, you know. But no, like, I'll look over, and it's just like, she got a whole bunch of like, you know, chicken scratch on her paper, and it's just like, what is it even like? She's got like random numbers and stuff going flying everywhere, and I'm like, is that I get confused.
Yeah, that's kind of how this one's going to be.
That's lovely.
I love that.
I mean, I was on the right track. I mean, that just makes sense. All right, so
Okay. This right here is this foiled. Okay, guys?
Yes.
Yes, ma'am.
All right. I just wanted to show you that kind of as a separate step because I'm going to actually combine right here this -4. Remember how we did this? Remember in one of the sections that we've done where we combined radicals? So if whatever was under the radical, you could combine them. So I've got a -4 and a -4, and you just added or subtracted the coefficients. We did that so that you would know how to do this when you got here. Because that's that little piece of information right there, plus 16. Okay?
A little star thingy below the
The
green.
star right there is the fact that this is just, that's not like, this is just this step of me foiling that. Does that make sense? And then this step, I'm carrying the problem on right here.
So you're also going to
like a side work.
Yeah, you're also going to square the 4 minus a, and that's in the thing, right?
I already did that, baby.
Okay.
I just didn't show it, did I?
No,
My
man.
bad.
So no, that's
I
all good. I was just making sure.
You were right. I just didn't write it. But you're so smart for knowing that.
But I do have
Okay,
a
so
question. So because
this
square,
step right here is this all is the next step. And this is kind of the side work, if you will, of this. Okay, what's your question?
so okay, when you square the 7a plus 4, that's just taking it out like it is on the in the very left part of the parentheses next to the green stuff. And then
Right.
what is going on with the middle sections there? Like I don't get that.
I love you. Yeah, I got you. That is, you know what? I probably need another piece of paper.
What the crap? Are
All
you
right, I'm
still
going
on like calculus like 10 already?
um. Oh man, you are the comic relief of my day every day, Braden.
Is that right?
Yes, baby.
Oh, man, that's such an honor. Yeah.
+4. All right. This right here, this is squared up here, right?
Oh, I think I just
So
figured it out.
if I square that, then I have to FOIL it. And this right here where the green asterisk is, you were like, hey, what's that star? That star is this foiled out. So remember outside. Okay, FOIL is first, and you saw that. You knew that this part was taking that out and moving it to there, right?
See, I got confused. You remember that one time in class you were talking about like when you see the squared symbol, you think it's just squaring, like the one time it's only all you like I just got the interpretation that all it's gonna do is make the 7a plus 4 go away, like the radical part of it go away, and then you're just gonna have a positive 16. Like that's what
Right.
that was. So I just gotta actually take it into. I see what it is now.
Yeah, you actually have to write it out because if you'll remember, and this is back when y'all were like, Miss Sparks, we have no idea what you're saying. Remember?
I'm still like that, Miss Sparks. Just letting you know.
Remember good old A plus B squared?
Oh, I missed that.
I said, really? I know. Really? When you write that out, that's A squared plus 2AB plus B squared. So what you're really doing is multiplying A and B and doubling it. Well, that's what you've done here is you multiplied those two together, but then doubled it.
Yeah, I see now. And then you're gonna get positive 16.
All right. Did that make sense, Brooke?
Yeah.
Okay, cool. You see all those things that we were teaching you back then, and you're like, no.
Yeah.
It's really to help you because we know what it's going to look like in the future. So we want you guys to kind of start seeing patterns.
Right.
And that's why. And so when you square something and it's a binomial, you have to remember it's going to be FOILed. That's why the difference of two squares is such a beautiful thing because that's really when you would end up with 7a plus 4 plus 16 because it would cancel out that middle term. But not so lucky here.
Wait,
It's
so the middle term, which is the -4 radical sign, 7a plus 4, and then that repeated. Can we take that and make it a wait a minute.
You're combining them. Remember, just like
Yeah.
we were combining radicals before Thanksgiving break.
Yeah,
As
so
long as that term matches, you can combine like terms.
so it'll be a -8 and then the radical sign and then 7a plus 4, right?
That's right. That's it. Exactly. And now this next part, what you're going to do is combine like terms again. So we have a like term here. There's a positive 4, and we have a like term here with a positive 16. So now we've got 7a plus 20 minus 8 times the square root of 7a plus 4. So now what we're going to do is subtract 20 from both sides. So that's going to give us a negative 16 minus a equals 7a minus 8, 7a plus 4. And then we're going to subtract 7a from both sides.
Wait a minute. Wait a minute. Hold on.
Why?
Why would you take the 20 and the 7 and bring it on the left side?
Because I
we're
need
not
to
how to do that.
isolate that radical to get it by itself, because I'm going to have to square it all over again. That's the goal.
I do have this kind of would be an important question. If I did not do that, and what I did is I added the a from the left side of the equation, put it in to the 7a to get positive 8a. Could I subtract it and still put it on the left side to make it negative 8a?
To make it a positive? Oh.
You see what I'm saying? Or am I still not making any sense? Yeah, like that. If I just took it on the, if I had positive 8a on the right side, could I just bring it over to the left side?
Oh, yeah.
Oh,
Yeah.
I didn't know if I was allowed to do that.
Well, I mean, as long as when you move it from right to left or left to right, you always have to make sure that you're moving it algebraically by doing the opposite.
I didn't do it algebraically, but I'm just going to do it and call it algebra.
Just because you can't just say, okay, I've got a positive 8a here, I'm going to move positive 8a to the other side. It just doesn't work that way.
Okay, so
you have to subtract it.
Yeah.
It sounded like to me that you were doing the opposite thing, but maybe I didn't listen well, and for that I apologize.
No, that's all good.
All right, so now I'm still trying to get that radical all by itself. That's the whole point, so I can square it again. But it is being multiplied by a negative 8, and so I have to get rid of that first. So I'm going to divide by a negative 8. All right. And so negative 16 divided by 8 is a positive 2. And a negative 8a divided by negative 8 is a positive a.
So why are we doing it?
Because we still have a radical.
Okay.
And we have to get rid of the radical.
Okay.
And so that's the whole goal. So now we're going to square both sides again. And this 2 would have to be foiled.
Mm-hmm.
So now we've got a squared.
So
I'm just going to turn it around. Is that going to confuse y'all?
Hold on.
Did that confuse you, Brookie, if I turn it around?
No, I'm fine.
Okay. I'm running out of paper.
Daggum, Miss
Me
Bart.
too.
Big equation. Yeah, I'm glad I did this on a separate sheet. About as long as the calculus problem.
Hey, Brooke and I wouldn't lead you astray. We're going to make sure you have it right. Are you caught up to us?
Yes, ma'am. Sorry, I just had to get the.
All right. I'm going to do this in one step since I'm running out of room. Will y'all hate me?
No, that's fine.
I'm going to subtract 7a and I'm going to subtract 4 from both sides all at one time.
So wait, just really quick.
Because I'm actually technically trying to get a quadratic, but
right.
I'm going to end up better than that.
Can you? So wait, where'd you get the 4a from?
If you square a plus 2, remember you have to FOIL that. A plus 2, a plus 2.
Why do I
A squared plus 2a plus 2a is 4a plus 4.
Let's see. It's
Okay. Once you get that, you would have to plug both of those answers back in to find out if there's any extraneous solutions.
Mm-hmm.
So what happens if you plug in the 0? 4 minus 0. So it means square root of 2 minus the square root of 2, which is going to be 0, and 0 doesn't equal -4. Did that make sense, Brookie?
Yes, ma'am.
Okay, so that didn't work, but 4 minus 3
wait a minute.
is 1, and the square root of 1 is 1 minus 7 plus 4.
So how the crap did that work out?
What, honey?
I'm talking to myself really right now, actually.
Okay. Do you see what I did?
I'm trying to figure out where the heck you got the a and then the a minus 3 deal from.
Oh, okay. All right. Do you see this very bottom down here? Can you see it? Where it says a squared minus 3a. Does that show up on the math lab?
Yeah.
It does? Okay. Equals 0?
Mm-hmm.
Okay. So, and then I actually rewrote it over here.
Yeah, that's what I was trying to figure out.
I factored the a out. And then that gives me a times a minus 3, which means a equals 0. And then I set each little factor equal to 0 to solve for my two answers.
So
then I've got 0 and 3. And then the next thing I have to do is plug them both back in up here, which means I need a whole nother piece of paper.
Wait, can you go back? I apologize.
No, yeah, I can. I was just going to see if it opens with that, with all my chicken scratch. So I have to plug in both of the answers. Did you do that already, Brooke, on your paper?
No, I didn't.
Okay. You have to plug both of your answers back in. Okay. Are you still writing, Braden?
Yes, ma'am. I apologize.
Oh, hey, no problem. And Braden, did you, they Lost and Found brought me a math composition note-taking book. Did you lose yours?
Let me check real quick. Nope, I got mine right here.
Okay.
Wait a minute. Wait a minute. Yep, I got it right here. It's all good.
Okay. All right. Well, I need to ask in the morning, and if it's not anybody in our class, I need to take it to Miss Wynn's.
Okay. Thank you for checking with me.
Oh, no problem. It's really pretty handwriting.
Well, that's definitely not mine.
Yeah, it is. It could be. I told him that you had nice handwriting.
Really?
Yeah.
Really? Like legit?
Yes.
Oh, thanks. Appreciate it. I mean, my numbers are not that bad, but my letters are crappy.
Yeah. Well, it's nice handwriting in the book.
Well, I appreciate that. But
All right. So we're going to go over here and check our answers now. Oh, sweet Jesus. It all came. Ugh. Ugh.
so your answer is gonna be 3, right?
Well, the answer is 3, but we got what 2 did we get? We got A equals 0 and we got A equals 3.
Yeah.
And you technically, if you're doing this on a test, you technically have to plug that back in to check it.
Do I have to?
Well, you kind of should, because if it wasn't multiple guess, you wouldn't know.
Yeah, you're right.
And the test isn't going to be multiple guess.
Dang it.
Zero does not equal -4. Now the other one is 3. So plug in 3, 4 minus 3 minus square root of 7 times 3 plus 4 equals -4. Square root of 1 minus 21 plus 4 equals -4.
So if I did
Square
number
root of
30, I could do number 41, right?
Oh, yeah.
Are you sure?
Yes,
Okay,
I'm positive.
I'll try it.
It takes a lot of paper. That's the only thing. So this is true. So the only valid answer is 3, and that's A on number 40.
Okay.
So did you take how many pieces of paper did that take up, Brooke?
Me?
Yeah.
Well, technically, I wrote it on my paper, but like I worked 38 like up like way up at the top. So it took like the whole side of like from where 32 starts to the bottom of 40.
Oh, that's hysterical.
Does that make sense?
Yes.
Yeah.
Oh, that's hysterical.
Starts.
I had to do when I was working this, I had to do a completely I just
Yeah.
did every problem on a separate sheet of paper.
Yeah, but my 39 took up the whole page. Like I did that one on another sheet of notebook paper.
Yeah, those are crazy.
Page. Yeah, it's kind of ridiculous.
I mean,
Yes.
I could show you this one. This one's just, I mean.
Wait a minute. Let me switch back over because I can only see the PDF when I'm here. Let me see.
Oh, you want to show you? Oh,
okay.
Yeah. All right. Well, yeah. So this is it. It's just, the whole entire paper. Okay.
That is a lot of work.
Yeah, it is.
It's like all of our algebra, like semester 1, like put into a problem. Literally every single thing we've ever learned in this semester in one problem. Like, it's so ridiculous.
Oh man, it
But
is,
what?
isn't it? Fine. Hey, maybe we should just make the final like 3 of these problems, and then that's
literally.
it.
Can
if
you
can
believe?
do one of these problems, you just know it,
You know what? I feel like if you can do one of these problems, you probably know the cure for the common cold.
Wait, are you
Yeah,
serious?
I
Like,
think
could
that's
you
about
actually do
right.
that? Could you please actually do that?
What?
Just put on 3 problems and do.
Yeah, but the thing about it is if you miss one, you're sunk.
Yeah, then the whole thing is just.
Well, then put on 4.
Because you're confident you're going to get 3 right.
I'm confident I'll get like 2 right.
No, you'd get them all right. All right. So, literally, let's see. The problem started here, and we went through all of that. And then here is our check.
Oh my gosh. Isn't
That's
that crazy?
Yes.
Like, for real.
Good times. So, did you get the whole worksheet done, Brookie?
Yes, ma'am.
Yay.
Do you want to
Yep,
send me
thank
that
goodness.
link to your sheet with?
Oh, all right.
Thank you,
Okay,
Miss
Brooke.
Sparks.
No problem. Thanks
I
for
hope you
coming to
have-
Math Lab.
Oh, you're welcome.
Thanks for making me smile. You and Braden make me smile.
Oh, well, I hope you have a good rest of your day.
Okay, you too, sweet pea.
Bye.
Okay. Bye-bye. Okay, Braden, you wanted me to do some at the beginning, right?
Yes, ma'am, if you don't mind.
I don't mind. Let's go back there. Where is it? There it is. Okay, which ones, buddy?
Let's see. Hold on 1 second. Let me just flip back over there. The front page was pretty easy. Let's do number 13 and 15.
13 and 15.
Yes,
Okay.
ma'am.
Okay. Well, the good news is you can see that you can combine some things up front if you wanted to do that first. You don't have to though, but it'd probably be a good idea though. So you know if the radicals match, you can combine. So this is an understood here. That's an understood -1. So I have -1 minus 3. So that's going to be -4 times root 54 minus 3
-4.
times root 45, right?
Oh, yes, ma'am. Hold on.
Okay.
I knew it was a -4. I just couldn't quite figure it out.
And so for 54, when you factor that, 54, 9 times 6, and 45 is 9 times 5. So to take that, 9 is a perfect square, right?
Yes, ma'am.
So and 3 is the perfect square. So 3 times -4 is what?
1 minute. 3 times -4?
Uh-huh.
-12.
-12. And then you whatever's left over, you have to put it in the root. And there's a 6 left over.
Okay.
Okay?
Wait a minute. Where did you get that from? The 3 and the 4.
Okay. This is why I like the other factoring a little bit better. But remember, I factored 54, right?
Yeah.
Okay. So and it factored you understand where I get the 3, correct? Or no? No?
I said
Okay.
yes, ma'am. Sorry.
Oh, okay. Because I was gonna say
Are you
like
saying probably the 3 and 4 of the?
so that came out, and then I have to multiply that 3 times that 4. Because it's on the outside of the radical.
Oh, okay.
So basically I have -4 times 3 times root 6, which turns into that, or not that, but the below it.
I see what you're saying.
You do?
Yes, ma'am.
Are you sure?
Yep.
So this then is going to be 3 root 5. Maybe I would have been better off writing like 3 root 6 here. So now I've got 3 root 5. So this 3 has to be multiplied by this 3. So what would that be?
-9.
Yep. And then you've got your root 5. Because you actually factored that out and took out all the perfect squares.
Yeah.
And so only the imperfect squares are left in there.
Awesome. Makes sense now.
Okay, good. Any others?
Number
I
15.
actually started with number 18 in the math lab if you just want to rewatch it a little bit.
Yeah, I might. Could you do
That way you can speed through whatever you don't want to watch.
Yeah. Could you do number 15, please?
Yeah. Okay. So I'm taking out the perfect squares, right?
Which is
Okay, so 125. I know there's got to be a 25 in it, right?
yeah.
And 25 is a perfect square, right?
Yes, ma'am.
And what's the square root of 25?
5.
So I've got a 5 on the outside. And I would have a 5 left on the inside. And what's the perfect square of x cubed? How many, what can you take out? X squared is, so, right? And what would be left?
Just a 5, right? Wait.
No, right here.
X. Yeah, X.
Right? What, and an X would be left, right?
Yes, ma'am.
Okay. And then Y, what's that going to be? Because basically what how many 2s can you take out of a 3?
It's just gonna be you're gonna have 5xy, and then you have the radical, and it's gonna be 5xyz. Correct?
Right. Yep.
Okay. Cool. Um.
And I started with 18.
Okay. Yeah, I think that's it, Miss Sparks.
There you go.
Awesome. Thank you.
Hey, no problem. I'll see you in the morning.
Alrighty. See ya.
Take care.
You too. Bye.
Bye-bye.